Have you ever pondered about the birth of the universe and our solar system? Our journey begins with the Big Bang Theory, the widely accepted cosmological model that narrates the epic tale of the universe's birth and evolution. Picture this: over 13 billion years ago, our universe was a hot, dense point nearly infinitely small, a concept we call the initial singularity. There were no stars, no galaxies, just a microscopic dot packed with extraordinary potential. Then, in an instant, this tiny point started to expand at an unimaginable speed. This rapid expansion, known as cosmic inflation, was so colossal that it stretched the fabric of space itself. Now imagine the universe cooling down as it expands. The temperatures dropped from unimaginably hot to merely 1 billion degrees, a period known as the cooling epoch. This cooling process was a crucial phase in the universe's evolution, giving birth to the first subatomic particles. From the seething chaos of this high-energy sea, particles of matter started to form. Quarks and leptons, the building blocks of matter, began to emerge. As the universe cooled further, these subatomic particles began to combine in various ways. After about a few 100,000 years, the universe was cool enough for these particles to come together and form simple atoms, primarily hydrogen and helium. This marked the end of the universe's early foggy epoch and the beginning of the transparent universe we can observe today. But the universe was not yet the star-filled canopy we gaze upon on clear nights. It was a dark place, filled with clouds of hydrogen and helium gas. Though simple, these atoms were the raw materials needed for the construction of the first stars, the celestial bodies that would ultimately light up the universe. From this primordial soup of elementary particles, the stage was set for the birth of the first stars. So buckle up as we continue our journey and delve deeper into the fascinating cosmic history. Imagine a universe dark for millions of years, suddenly lit by the birth of the first stars. In the wake of the Big Bang, the universe was a hot, dense soup of particles. As it expanded and cooled, the first atoms began to form, primarily hydrogen and helium with traces of lithium. In this early universe, there were no stars, no galaxies, just a vast expanse of these primordial elements. But over time, gravity began to weave its magic. It pulled these atoms together, forming clouds of gas that grew denser and hotter, until finally, under their own weight, they collapsed and ignited, giving birth to the first stars. These were the so-called population 3 stars, the first generation of stars in the universe. These stellar pioneers were unlike any stars we see today. They were massive, often hundreds of times the size of our sun, and with their great mass came great energy and consequently, short lifespans. These ancient behemoths lived fast and died young, often in spectacular supernovae, the largest explosions in the universe. The death of these first stars was not in vain, though. In their fiery furnaces, they forged the first heavy elements. Elements like carbon, nitrogen, and oxygen, the building blocks of life as we know it. And when these stars exploded, they scattered these elements across the universe, seeding it with the raw materials for the next generation of stars, and eventually galaxies, planets, and life. The formation of these first stars was a turning point in the history of the universe. They brought light to a dark cosmos, kick-started the process of chemical evolution, and paved the way for everything that was to come. But perhaps most importantly, they set the stage for the incredible diversity and complexity we see in the universe today. These first stars not only illuminated the universe, but their explosive deaths also seeded it with the heavier elements necessary for the creation of galaxies, stars, planets, and ultimately, life. From the remnants of the first stars, galaxies, vast cities of stars were born. These grand cosmic metropolises came into existence as colossal clouds of gas, enriched by the elements forged within the hearts of the first stars, began to gravitate towards each other. These clouds of gas, teeming with the remnants of the universe's first luminaries, were the birthplaces of galaxies. Under the relentless pull of gravity, these clouds began to collapse onto themselves. The pressure and heat at the core of these collapsing clouds triggered the birth of new stars, each one a shining beacon in the growing city of stars. But what guided these gas clouds to form galaxies? And why do galaxies cluster together, forming larger structures in the universe? The answer lies in the enigmatic and elusive dark matter. This mysterious substance, undetectable by our current instruments, makes up about 85% of the universe's matter. Dark matter, though invisible and intangible, exerts a gravitational pull, shaping the visible matter in the universe. The clumps of dark matter attracted the gas clouds, serving as cosmic scaffolding around which stars and galaxies formed. Dark matter's gravitational influence didn't stop there. It also played a crucial role in the formation of galaxy clusters, the largest structures in the universe. These clusters, each containing hundreds to thousands of galaxies, are a testament to the immense gravitational force of dark matter. As we traverse through the cosmic timeline, we encounter a staggering array of galaxies. Spirals with arms of stars swirling around a central bulge, ellipticals packed with billions of stars, and irregulars with no definite shape. Each galaxy, a unique blend of gas, dust, stars, and dark matter, is a city of stars with its own story to tell. Among these countless galaxies, a particular one holds a special place, our own Milky Way. And within this spiral galaxy, in one of its outer arms, lies an even more special place, our solar system. But that's a story for another scene. For now, let's marvel at the grandeur of these cities of stars, each one a testament to the cosmic saga of creation and evolution. In an unremarkable corner of the Milky Way, around 4.6 billion years ago, our solar system was born. Imagine, if you will, a vast swirling cloud of gas and dust, a nebula. This nebula, under the influence of gravity, began to collapse in on itself. As it did, the material in the center of the cloud grew denser and hotter, eventually forming a young star, our sun. Around this young star, a flat disk of remaining dust and gas began to take shape. Within this protoplanetary disk, countless particles started to collide and stick together. These growing clumps of matter, or planetesimals, were the building blocks of our solar system. Over millions of years, these planetesimals collided and combined, growing larger and forming the planets we know today. The inner planets, including our Earth, were formed from the heavier elements, while the outer gas giants formed from the lighter elements in the outer regions of the disk. Now let's talk about our unique home, Earth. Its location is nothing short of extraordinary, situated in the sweet spot known as the habitable zone, a region around the sun where conditions are just right for water to exist in all three states, solid, liquid, and gas. This perfect position, along with the presence of a protective magnetic field and the right blend of elements, provided the perfect conditions for life as we know it to take root. Earth, as far as we know, is the only planet in our solar system where these conditions have come together to create such a diverse and thriving biosphere. From a simple cloud of gas and dust through vast cosmic forces and countless collisions came the birth of our sun, our planets, and our unique home, Earth. The birth of our solar system was not just a cosmic event, it was the beginning of our own story. A story that continues to unfold as we explore the cosmos and uncover the mysteries of our place within it. The birth of our solar system was not just a cosmic event, it was the beginning of our own story. From the birth of the first stars to the formation of our solar system, the universe has been a stage for cosmic ballet. As we draw to a close, let's take a moment to reflect on the awe-inspiring journey we've embarked upon today. We started at the very beginning, the birth of the universe, a moment of unimaginable energy and matter expanding rapidly in an event we now call the Big Bang. From this chaotic birth, the universe as we know it began to take shape, a canvas upon which the first stars would soon be drawn. The formation of these stars marked a pivotal moment in the universe's history. These celestial bodies ignited for the first time, piercing the darkness with their light and setting the stage for the galaxies to come. They were the first luminaries, the pioneers in a universe that was still finding its identity. As these stars lived and died, their last breaths gave rise to galaxies. These cosmic cities teeming with countless stars became the backbone of our universe. Each galaxy, unique and diverse, reflecting the beauty of cosmic creation on an unimaginable scale. Yet among these cosmic metropolises, a particular one holds our interest, the Milky Way. In its quiet corner, the birth of our solar system took place. From a swirling cloud of gas and dust, our sun sparked into existence, followed by the planets, including our very own Earth. This marked not just the inception of our solar system, but also the beginning of our own story within this vast universe. As we traverse this cosmic narrative, it's important to remember how interconnected we are with the universe. We are, after all, made of stardust, the remnants of stars that lived billions of years ago. The next time you gaze at the night sky, remember you're not just looking at stars, you're peering into the cradle of the universe, and in it, our own cosmic origin story. So the next time you gaze upon the stars, Remember this journey, remember our place in this grand cosmic ballet.